If f of x equals 1 divided by x minus 3 and g of x equals 3 divided by x minus 3, generate a table of values and a graph to represent f of x and g of x. Select a method to generate h of x equals g of x minus f of x, and use the equations, tables, and graphs to compare h of x with f of x and g of x. Okay, so let's go ahead and generate a table of values of these first. So just plugging in these different values, if we plug in 0 to f of x, we get 1 divided by 0 minus 3, which is negative 3, so negative 1/3. And then plugging in 1 divided by 1 minus 3, 1 minus 3 is negative 2, so that's just 1 over negative 2, or negative 1/2. And then using that same method, I'm just going to go ahead and fill in the rest of these. Okay, so just wanted to point out here that at 3 we do have undefined because 3 minus 3 is 0 in the denominator, and that makes it so that we cannot have 1 divided by 0. That isn't possible, so that's just going to be an undefined value where the asymptote will be. And then for g of x, then similarly, we have 3 divided by 0 minus 3, which is negative 3. So 3 divided by negative 3 is negative 1. And then with the same thing, I'll fill in the rest of the values. Okay, so we see that now we have both of the values. And so then to find h of x, then we're just going to subtract g of x minus f of x. So g of x minus f of x, so we're looking at this backwards here. So negative 1 minus negative 1/3 is just plus 1/3. So it ends up, so we're going again from right to left here. So negative 1 minus negative 1/3, that's plus 1/3. So that's going to be negative 2/3. And then so on, just subtracting these, negative 3/2 minus negative 1/2, that's plus 1/2. So we're just ending up with negative 2/2, which is the same thing as negative 1. And then negative 3 minus negative 1, that's plus 1. So negative 2. Undefined will still be undefined if we subtract those since there's no value there. And then 3 minus 1 is 2, and so on. We get these values. So here are our h of x values. Now let's go ahead and graph these. Okay, so we see that we have, I just plotted our f of x, which is the blue line, our g of x, which is the green line, and then h of x I plotted, which is the orange line. And then just notice that because of those points that I used, then you can type this into a calculator and you get the same exact results on these graphs and the same exact points in your table. And on the actual graph itself, when taking the y values, the same as what we have in the table, when we subtract those, we do get the y values of h of x in our graph. And so that is our graph. Now let's go ahead and find the equation as well. So to find the equations, this is pretty simple. We're just going to take, again, h of x. We know that that's just g of x minus f of x. And so g of x is 3 divided by x minus 3, and then minus f of x, that's just 1 divided by x minus 3. And so since they have the same denominator, that's just subtracting two fractions, so we can just subtract the numerators there. So 3 minus 1 is just 2. So we're left with 2 divided by x minus 3 equals h of x. And so just notice here that we will have a horizontal asymptote at c divided by b. So here c is 3 and b is 1. Okay, and so 3 divided by 1 is just 3. And so we know the vertical asymptote will be x equals 3, and then there's no value for d at the end there, so that just means d is 0. So that means y will equal 0 for the horizontal asymptote. So let's check those in our graph. Okay, so we do see that we'll have a horizontal asymptote at 3. I'll mark that in here. Vertical asymptote at x equals 3, and then our horizontal asymptote is at y equals 0. And then, so our equation does fit there. And so we can go ahead and summarize our answers, and we do see that the table and everything matches here. To summarize our answers, we have our graphs and our tables. We also have our work for finding h of x. So h of x equals g of x minus f of x, which equals 3 divided by x minus 3 minus 1 divided by x minus 3, which equals 2 divided by x minus 3. And then here's our comparing them. So comparing all three representations, h of x is a rational function that is the difference of two other rational functions, g of x and f of x. Since the rational functions f of x and g of x have the same denominator, it is possible to determine h of x by subtracting the expression for f of x from the expression for g of x. Although a table has a limited number of values, you can choose input values, substitute them into the equations for f of x and g of x, and then subtract each output value of f of x from each output value of g of x to determine output values for h of x. These output values, when paired with their input values, can be plotted on a coordinate plane with graphs of the functions f of x, g of x, and h of x to show how the equations, tables, and graphs are related to one another.